Welcome back, guys. This is the 19th video tutorial of Core Java, and today we are going to discuss about the very important topic in Core Java, and mostly the interviewers will ask these questions in this topic. The topic we are going to cover today is collections. Hope you guys know about brief about this, right? Even if you don't know about this, you can get good knowledge in this now. So the collection in Java, it's a framework that provides an architecture to store and manipulate the group of objects. Suppose if you want to store a group of objects into one variable, and if you want to manage them, like manipulating them on the group of objects, so these kind of operations can be achieved using collections. So Java collections can achieve all the operations that you can perform on data, such as searching, sorting, insertion, manipulation, and deletion. So all the operations. Suppose if you take a collection, any of the collections, so you can able to do all the operations. Either you can able to add a new element to the collection. So unlike arrays you will be having, and arrays will not allow multiple elements to be added dynamically, and so that is possible in collections. You can able to add and remove, and if you want to modify, or if you want to replace anything, and if you want to search any element out of it, so these are all possible. First we can see how the typical array will look like. Suppose this is an array of elements. Suppose you will be having elements like 10, 20, 30, 40, and 50. Suppose if you have a set of elements which are 10, 20, 30, 40, or 50, or if so, these is an integer array. You can say integer array, and if you want to create an integer array, so there will be fixed line of elements you have to create, and you have to reuse the same array. Suppose the declaration will be int. So I'm creating int type of array, which is x. I'm creating, which is, or I can mention as array equal to, I'm just having elements like 10, 20, 30, 40, and 50. So if you have this kind of array, so this is the way of declaring an array and assigning values to an array. So the size of the array will be, it's a 5, and you cannot able to modify the array. Suppose if you want to insert an element, or so if you want to do plus of some elements, so if you want to do addition of any elements and all, it's not possible using arrays. So if you want to add more elements to this array, this is quite impossible in arrays. So this is not possible. If you want to edit any array with like any kind of modification, suppose if you want to replace an element within array, that is possible. But if you want to delete an element within this array, that is not possible. If you want to add an element to an array, that is not possible. So if you want to insert any element, that is also not possible. So all the edit operations is not allowed, and this is the fixed length array. And if you want to add any element means you have to create a new array, and you have to reassign all the elements to that, and you need to add the new element also within the latest sized array. So there are there are a lot of problems we'll be facing with the arrays because we are not able to modify the defined array. So the main advantage with collections will be to overcome this problem. So we can able to do all the operations. Suppose these and collection, if you think the same set of collection, if you think, so the same set of collection, if you think, so in collection it is possible to do all the operations. Suppose you can able to add an element and delete an element and insert element. Inserting means in between in some range of elements you want to insert any element. Suppose to in between 20 and 30, if you want to do insert any element, that is also possible in collections. And update an element. So if you want to modify any existing element, so even this is possible in arrays by mentioning the index of the array, and here we'll be pointing in different ways. Either you can able to mention the index of the array, or you can directly mention the element of the array. So the way to do this is either you can mention, suppose 30 if you want to replace. So in arrays it will be like 0, 1, 2, second position you have to replace the element. But here in case of collections, you can able to do through indexes along with the values also. With the directly pointing 30 value, you can able to replace it. So that is the update of element, and you can able to search an element. So searching an element also possible in the arrays, but the way to do is you have to traverse whole the array, then only you can find out the where the element will be, and you have to return that element. But in terms of collections, you don't need to have that much complexity. You just need to give such of such methods will be there for searching an element within the collections. So these are major difference between arrays and collections, and here I can say add element not possible, delete element not possible, insert element, these also not possible because it is not allowed to insert an element in between some elements. Suppose in between 20, 30, if you want to insert an element, this is not possible, but in collections it is quite possible. And update element, which is if you want to replace any element, this is actually possible. And search an element. So search element will be possible, but it takes time, more time to search. So these are about the major difference between arrays and collections. So all these operations can be done, and so array is a type only they have predefined means a predefined length we have to define. Suppose these the way I have assigned elements. If I want to create an array with some size of it, so the way to do this is int new int of fixed size you have to give, either 10 or in this case in our case it is 5. So these are we have to declare an array. Either you can create and assign the elements, fixed number of elements, or you can create a fixed size of array, then you can add the elements within it. So these are only the possibility, and you cannot able to increase the size of the array. Suppose if you created a 5 size array, then you can able to insert only 0 to 4 indexes, which is 5 elements only you can able to insert. Out of 5 you cannot, it is not allowed to insert. But in terms of collections, so you can able to insert n number of elements. It depends on your by using add method you can able to add n number of elements. There is no number limit for that, and there is no predefined limit for that. That is a major difference. Coming to collections, so there are lot of collection libraries are available, lot of collection classes are available in Java. With those classes you can able to achieve manipulating multiple objects together. But this one particularly in arrays you can able to handle only the set of elements, and modifying array will be very difficult. So these are about brief about arrays and collections. Now we can see what and all we can able to work with collections, and what kind of classes we have, and what are the types of classes we have in collections. We can see it now. I'm just saving this with downloads folder. So I'm just saving with one. That's it. I'm just created a new file which I want to show what collection hierarchy will be. I mean collection classes hierarchy. I can mention hierarchy of collection framework. So now I'm going to draw a diagram which is actually refers what are classes available and what is the hierarchy it will be having, depends on the parent classes and child classes relationships I'll be mentioning over here. So the top class will be for the collections is named as, I'll put it in little bit top, so we have a lot of big hierarchy picture here. So the top hierarchy will be the interface, which is named as iterable. So these is the top interface we have in a collection, and this will actually contains all the collection related subclasses. So this is the parent class for the iterable is an interface which is the parent interface for all the collection classes. Under that we have one more interface which is called as collection. So collection is another interface which is comes under iterable interface. So under this collection we have a different set of classes which I'm going to show you. So as we see, iterable is an interface, and under that collection is an interface. Under that there are three different types of interfaces are available, which is comes as list and so there are three, as I mentioned, there are three types of interfaces are available. One is list, the other one is queue, the other one will be set. So these are all belongs to the parent class, which is collection. So under collection interface, we have three different interfaces, which are list, queue, and set. It's not coming here. So these is the hierarchy of the major interfaces. The first one you have to remember as iterable. The second one will be the collection interface under the iterable, and there are three different interfaces, which are list, queue, and set. Make sure, guys, you have to remember this diagram when you are in interviews. Then you should draw this diagram so that the interviewer can understand how much good knowledge you have it in the collection framework. So then the list will have set of classes. This list is having set of classes. Also the same way, first we can see the list classes, what are list classes is available. Also the same way, like we have the set of classes for queue and we have set of classes for set. First we can see what are the classes we have it in list. The classes will be array list, there is no space, array list, and linked list, and a vector, and a stack. So these are all the set of classes available within list interface. The stack is not directly comes from list interface, it actually comes under the vector. But all the other classes are comes directly from list interface. So in iterable is an parent interface. Under that we have collection interface. Under that we have three different set of interfaces: list, queue, set. So under list we have three different classes, which is array list, linked list, and vector. Under vector we have a stack class. So these are the hierarchy for list interface. Now we can see what queue is having. Queue is having an interface which is called as the queue, or we can directly have a class which is called priority queue. It's come under the queue interface. Likewise, the same way we have set of classes available under set interface, which is hash set and linked hash set. So make sure, guys, there is no gaps in between the names of the collection classes. So you can remember this way, like what are the boxes it is having, the names whatever I mentioned, which is mentioned as interfaces, and what are the classes I wrote without boxes, like hash set and linked list. These are all you can consider as classes. So these are the typical architecture of collection framework. There are other classes and also available. For now, this will be more than enough for us. So what we have seen, we have seen the, let Let me drag this to one place properly. So I'm just aligning. So I need to cover a few more topics in this diagram. That is the reason I'm just dragging this to a side so that we can cover other topics as well. So there are other collection interface classes we have, those we need to cover. For that reason, I'm just dragging this to the side, a little bit aside. So as I mentioned, what are the boxes are there? These are called as interfaces, and what are the names I mentioned outside the boxes? So those are called as classes. So we have a triple interface collection under that, and we have three set of interface: list, queue, and set. Then we have array list, under the list, and linked list, and vector. Now we can go through one by one. First we can go to the list interface. Then we can see what and all different types of methods are available in list, and how to actually reuse that. First we can see that. For that, I'm just going to Eclipse. I'm just creating a package which is called as collection framework. I'm just creating a package which is named as collection framework. There I'll be demonstrating array list. So I'm just creating a main method. It's a simple. Here I'm mentioning so the first we are going to cover the list related classes, which is the array list. As you see, list is a parent interface for array list class. So I'm just creating array list object. Array list. If you see, this comes under java.util package. Make sure guys, all the packages, all the collection classes comes under java.util package. So what are the collection classes we'll be writing? All are from java.util package. That's a one important interview question that you have to remember and you have to answer in interviews. Java.util, and it is asking for enumeration. So what is enumeration? Enumeration is called as the data type, which data type you want to create an array list. So I'm giving data type as integer. Array list equal to new, simply array list of. So this symbol will come because this is the type of what kind of we are giving the data type of. Either we can mention the data type here also, or if you don't mention also, there is no problem at all. So this is actually mandate in the previous versions of Java 7 and all, but after Java 7 what they did was, this is not required. Anyhow, we are mentioning that data type in the left side, so that will be more than enough. So here we just need to put empty brackets. That will be more than enough. So now I just created an object. So the object is like, I just created an object. So size and all I haven't mentioned here. It's a just object. So as many elements I want, this size will grow. What I'm doing is I just need to add the elements within that. So for that, what I'm doing is l dot see, there are set of methods are available within add different methods. So suppose one is add all, contains all. Contains means whether the element is contains or not, and ensure capacity. If you want to, what is the capacity? If you want to know, that's ensure the capacity. And because I have a Java 8 version, this method is populating for each method. So these we will discuss in Java new advanced features. That topic when we're discussing there, we can discuss it. For now, we can just ignore it. And get method, which is used to get an element. Suppose if you have elements of set of elements, if you want to get any element by the index, you can able to get it, like how we are doing in arrays. So index of if you give any object, suppose 10, 20, 30 will be there, and if you give 30 for this method index of, so it will give the index of particular element. And isEmpty method is used to check whether the uh, array list is empty or not, and iterator will be used to loop through the element. So if you want to loop through the element, then you can use the iterator, and we're going to discuss about this in a couple of minutes. So these are will be having lots of elements. If you want to remove any element, so these is not possible in arrays, but in collections it is possible. So array list is also part of collection, so it is allowing to remove any element by the index or by the object. Or if you want to remove all, if you give any other collection to the input, so it will remove. Don't get confused, guys. We'll get to practical everything, and then you can remember easily. So these are the size is the important method, which is actually return the size of an array list. So what is the capacity, or what is the number of elements are available in the array list. And the sub list, if you want to split an list into two lists and all, you can able to do that. And two array, if you want to convert this to array, like how we have the general array, you can able to convert it to array of elements. So likewise, we have a lot of elements here. First we can see adding an element using add. See, it is asking for add, it is asking where an element. The second one will be what index you want to add it. If you want to add it any index specific, then you can able to add it, which is mentioned as inserting an element within an array object. Add all will mention adding other collection to this. For now, we can go with the add element. So I'm adding a 10 dot add of 20 add of 30 dot add of 40 dot add of 50. So I have added 5 elements out of it. So if you see in our array how the elements will be, so if you think this is an array list, what I'm doing is I'm just adding elements here. 10, 20, 30, can make more space, 10, 20, 30, 40, 50. So these is an array list example I'm mentioning. So the elements I'm storing 10. I'll show you why I'm drawing this diagram. I'll show you 20, 30, 40 and 50. See, we have added 5 elements as per Java code. So if you want to add one more element, again the space will be created for that. It will be added in the list. So it's not like size restricted. If you want to add, you can add in number of elements. So what I'm doing is I just print the elements of an array. We'll see how the output will be. I'm just printing array list. Nothing much I'm doing. I'm just printing it. Just running as Java application. See, it's printed as array of elements. Here it is showing as an array, but it's a collection of elements, which is 10 to 50 elements we have added. What are the elements we added? It's printed. What will happen after I printed if I add 60 and print elements again? So here I'm adding one more element after I printed. We'll see that. See, before adding it's a 50, after adding it's a 60 elements. So 60 is also added as part of elements. There are 6 elements in this array list. So this is the standard way of adding an element. So I don't want to loop. I don't want to print this array like this. I just want to loop it, and I just want to print the elements one by one. The way to do this is you have iterators. For looping any elements, you have iterators. what I'm doing is list dot or al dot iterator. We have seen this right when we are iterator. So iterator is an interface which is used to loop our elements. If you see this iterator, where it is actually, it is based on top of the all the collections. So these the iterable interface, and inside that iterable iterator will be there. Iterator is used to loop through the elements. So what is the return type for this? Iterator. So I just need to import this one in java.swing. Java.string, it's from util actually. All the classes, as I mentioned, we have to import from java.util. So there is other package which is available in string package, but this is not required. For our case, it's a util. So I just got iterator for looping an elements. The way to do this is while of it dot has next, means until the elements are available, just loop through it and print the element in it. It dot next, which is used to print the elements. So what I did was I just created an array list, then I created an iterator for that to print the elements. Now we see the output how it looks like. See 10, 20, 30, 40, 50. I can able to loop through the elements, and I can able to print the elements. So what will happen if I don't want to use this iterator? So there is other way also you can able to print it. There are different ways you can able to print it. I'm just clearing this output. The other way will be the regular for loop. You can use it, and instead of that, why should I use a regular for loop? I can use for each loop. For each loop we already know, which is the way to do this is integer item equal to al. So I just given the al, and I'm just getting one item within the al, means array list. I'm just printing the elements. So I'm just printing the element. We'll see the output now. So which is same. There is no difference between printing with iterator and for each loop. On your convenience, you can use either one. And most of the IT people in industry will be used this for each loop very frequently to print the elements, either in array or in a collection like array list and all. Anything people will prefer to use for each loop for making quick code, and they can understand easily. So these about creating an array list, and these about looping an elements and how to print that. So before we going to next topic, which is linked list, first we can see here array list is come under list interface. So can't I create a reference variable list instead of array list? So I'm creating a reference as array list, right? Instead of, what I'm doing is I'll be taking list as an interface. So that is actually recommended to do in real time. So I'm just importing it from java.util. That's it. So there is no difference between the output, it will be same. This is the standard way of declaring an interface. If you are aware what is the parent class for that or parent interface for that, it's good to define with the parent class in reference variable and assign the subclass object. Sorry guys. So this is the standard way of declaring any collection class or any regular class. So that's about array list. We have seen how to create an integer elements and we can loop it. Also we can see how to create an array list with string elements. So the different type I want. The way to do this is simple. List of string L2 LT2 list2 new array list of LT2 dot, So what is the type? We have added add of strings. We need to add name1. I'm just adding multiple elements here, name2, name3, and I'm just printing those elements, lt2. For now I'm just commenting this code to print those string elements. Run as Java application. So I have created a string type of array list. This is the regular syntax for creating an array list with a string data type, and I'll be adding few elements over here, and I'm just printing it. So what if I want to delete any element? Remove at index. Of index you can give, or object also you can give. Now I can see object name2. Sort lt2 will print this element. What and all will be there in the after removing any element. See, the first what I did was I just created an array list with the 3 elements. After that I just printed the elements out of it. So now we got 3 elements. After that what I did was I just removed an element with the content of the element. So the element got removed, and if you see the list now, and it is removed one element, it is the size is 2. Also you can check a size method. The way to do this is size dot lt dot size. Size of list is lt2 dot size. So I'm just printing the size of an array list. See, after removing, the size of the list will be 2. What will happen if I copy paste this one, and I'll print here. Once the elements are printed, I'll print the size of the array here also. We'll see the output now. So after setting 3 elements, the size of the list will be 3. After removing, the size of the element is 2. So these are we can able to do all kind of operations in any collection. Now we have tested with array list. Now we can see what is the other class, which is linked list. So linked list is also similar to a list interface, which is used to adding an element, multiple elements, and it will actually return a collection of elements. That if you can do all the operations what is done through array list. I'm just creating a main class, main method. Another, I'm just creating list of integer. So we already know linked list equal to new linked list. So linked list also comes from java.util package. So here I'll be mentioning the data type as integer. I'm just importing list package over here. So what I'm doing is linked list dot add of 10, dot add of 20, dot add of 30. So I have added set of elements here. I'm just printing linked list. What will happen? It will print 3 elements. Size of linked list is dot size. So we have seen adding elements through list, which is a list, and we have seen how to add elements in linked list. But you see in the programming, right, there is no difference at all. So what will be the difference between list and array list. If you see here, right, a list and array list, there's no much difference. You're just creating the name you're putting as array list, and here you're just putting name as linked list. That's only the difference. Other than that, there's no difference at all. It is just working as similar to the array list. So we'll see what is the major difference between list and which is array list and linked list. Just removing it. So there is a difference between linked list and array list. The major difference will be array list internally uses dynamic array to store elements. Suppose what is the array list we have, it is actually used array concept itself, and it is actually used a dynamic array concept. Like if the size is increased, and it is actually re-increase the array, and it is actually assigning elements to it. So it is used as dynamic array concept in array list. But in terms of linked list, uses doubly linked list in to store elements. So I think you guys have some knowledge on linked list and all. So if you see array list, the list will look like how we wrote right the previous. It will be a single array, which is dynamic array. You can able to add elements dynamically, so that array also resized automatically, depends on the elements you're adding. So array list is simple array which is having set of elements here. This is a simple array, nothing difference. And if you see the array linked list, the structure for the linked list will be doubly linked list, which is looks like so. This will be a header element, header. This will be the next element, and this will be the data. So this will be the data. The same way, this will be the previous element index, and this will be the data. This will be the next element index. Because I'm mentioning header here is it is actually pointing to header, the first element, because of its first element. So this will be the double linked list concept, and we can have a separate tutorial for data structures and algorithms. So there we can discuss more about how to have linked list and all. Will actually we can able to create our own classes, and we can able to make them work as linked list. So these are the major difference between linked list and array list. In array list, it will be consecutive elements, which is actually dynamic array. In terms of linked list, it is double linked list array, which is looks like this. It will have the individual elements, and it is containing data and along with the addresses of next element and previous elements. So that is a major difference. And manipulation with array list will be slow. If you are doing any manipulation, right, in this case, so if you are doing to edit any element, or if you want to remove an element in particular places, so this will be slow. The reason is every time it has to loop through this element, and it has to delete that particular element. Again, it has to resize that array. So for that reason, it will take a lot of time to make modification. In terms of linked list, suppose if I have one more linked list, which is about there are, if you think like there are three objects are there, it is having Suppose these three elements are having linked list. Suppose if you want to delete any particular linked list, suppose any data within this, so the way to do this is just unlink this. It will just unlink this element, unlink this element, and just link to the next element. What are the next consecutive elements is there, that link it will directly point. So this is simple, this much simple the linked list will do. That is the reason it will be very much faster compared to the array list. So array list will be slower because it has to loop through all the elements. So once it is element is removed, then again it has to resize the array. But in terms of linked list, it is simple. It's just unlinking an element and it is linking the next element. That is the reason it will be fast. And array list is better for sorting and accessing. Suppose if you have any sorting related things you have to do, so this will be the faster, and linked list will be expensive. So this is taking a lot of time for if you want to sort or something. For modification related things compared to array list, linked list will be the faster. So these are all the major differences between the list and array list, sorry, array list and linked list. So make sure guys, you should remember all these concepts, and the diagrams you have to keep it in your mind so that you can explain to the interviewer properly. Now we can see, so these about array list and linked list in between inside the list interface. Now we can see the next interface, which is set. Later we can go to the queue. So I'm just clearing this to make use of other topics and use the space to explain. So now we are seeing it set interface. So what is a set interface? If you see programmatically, there is no much difference between set and list, but the difference will be, suppose in a list, suppose if you have elements like 10, 20, 30, right? If you have 20 one more time you added, so what will happen? It will just add this 2 times 20 is added and it's just printed. Because it's a collection, it just hold an element, it just printed. There is no difference at all, even if you add duplicate elements and all. But in terms of set, if you want to avoid any duplicates, so if you don't want to add any duplicate elements to the collection, then set is an interface we have to use it. So as we listed here, there are two different implementations that are available, which is hash set and linked set. I forgot to mention in linked list. So there is one more difference between list and array list and linked list. The difference will be like the way you insert in a list, array list will be, there's no guarantee when you're printing the elements, there's no guarantee of printing in the same order. But in linked list, there is a guarantee. So the way you inserted a list, the same order it will actually print in the console. So that is a major difference between linked collections. Not only the list, and even here in hash set also, it will actually same. The way you inserted the same order, it will actually print the elements. That is the major difference between regular collection and the linked collections. So come back to the set interface. As we discussed, it won't allow duplicates. You can here itself we can mention list is allows duplicates. All the list elements allow duplicates, and set not allow duplicates. So these are major difference between the set and the list interfaces. So you should remember this topic so that you can able to explain to interviewers saying the major difference is set will not allow duplicate elements. Sorry guys, some noise. So I'll just pause the video. So these are if you comparatively see the difference between set and list, so these will be the difference. And list will allow duplicates, and set will not allow duplicates. And the major functionality of set will be like it will do the hashing. So if you see the set classes, right, the classes are hash set and linked hash set. So hash set stores the element by using mechanism called hashing. So with the hashing mechanism, it actually stores the element. And yes, hash set also will allow null values. Even the linked list also will allow null values. Now we can see how practically we can implement a hash set example, and we can see how it is not allowed duplicate elements. So in our case, the same set of elements are supposed to add it in the hash set. We'll see how hash set will work. So I'm just creating a main method. So I'm just creating a hash set class reference, which is from java.util. Type I'm mentioning integer, hs equal to new hash set of. I'm doing hs dot add of. So as I mentioned, I'll be adding the same set of elements 10, 20, 20, 30. The same set of elements I'm supposed to add it. 10 hs dot add of 20 hs dot add of 20 again hs dot add of 30, and I'm printing the size of a hash set, which is size just giving hs dot size. So size will be there in hash set as well. I'm just printing elements, which is hs. I'm just printing. See, for printing you can use the same code. There's no difference at all. Iterators you can able to use it, or for each loop you can use it extensively. You can print it either ways. I'm just printing the list here. I'm just printing this way. After the size, I'm just printing the elements I want. Using for each loop, we can print it later. First we can see whether it is allowing duplicates or not. The expected will be the size will be 4 and the list of element 10, 20, 20, 30, but it is allowing it is not allowed duplicates, right? It should be the size will be 3. We can see the result now, how it will remove the duplicates and how it is acting. See, it is having, sorry guys, I just run the linked list example. That is the reason it's showing 4 elements. So I will run and see the hash set now. See, the size of the hash set is 3 and there is only 120 available. If you see the result in array list, right, it is actually printing allowing duplicates. 220s are there, and the size of the array is 4. And here I'm just adding the same elements, and here I'm getting the size is 3 and the duplicates is not allowed. It is removed one duplicate element, whatever it is just removed it. So the other way to print the elements, instead of printing in single statement, we can loop through the elements. The way is, for each loop I'll be using item hs. So it is, which is same as our array list how we printed. So item I'm printing, just run as Java application. See, you're getting the elements, which is 20, 10 and 30. So these are the difference between the array list and hash set. So the same way you can able to add string elements as well. The way to do this is, you just need to change this to string, the data type, whatever you want. You can mention it as true. Then you just need to add the elements. Add of name1, add of name 2. Likewise, you can add a number of elements and you can do all the operations what you want. Double quotes, this out hs2, just printed the elements of array C, the list also printed. So not only these data type in array list and set data type, you can have your own data type. Whatever the data type you have, you can have it. Any other data type also you can have it. Suppose I'm just declaring as set of student, which is from different class. We have student in serialization and aggregation. So many places we have student, right? I'm just adding one student object. st set or student set. New student, sorry, hash set of. So even you can have student objects, and you can the way to adding student objects will be st equal to new student of. I think it is expecting some constructor. You can see it, which is roll number and name. So I'm adding those elements. Roll number is 1 and name is James. And I'm creating one more object. Is it same order I have to pass? Roll number and string is James. So I think constructor visibility is not public. I just need to make the constructor to be visible public so that this can be able to access. So now I have created student 1, which is James, and I'm creating other student, which is student 2, which is Geo, student 3 is Thomas. So I'll be changing the row numbers for them. So I have created 3 different objects. The way to adding student set will be just click on student set dot add of, same thing, st1 student 1 student 2 and student 3. Just print the element. This is the top student set. So for now I'm just commenting this for loop, just uncommenting this one to make you understand better. So what I did was I just created a student type of hash set. I just created 3 student objects. I just added to the set and printing the elements. We'll see what is the result will be. Now we can see, I'll comment this one also for better understanding. Just rerunning it. See, we have 3 types of examples we have seen. One is integer type of hash set, other one is string type of hash set, another one will be the custom type, which is student type of hash set. So both the types are allowed in the hash set. The same way you can do it in array list as well. So array list also you can have the same set of examples, you can try it. But remember guys, only the difference between set and allow, the set and list will be set will not allow duplicates, but list will allow duplicate values. That's only the difference. So these are we can able to add our custom types in hash set. Also we can use same for array list as well. So now we can see linked hash set, which is the other class within set interface. We can see that now. Linked hash set is also similar to array list. Linked array list we define. It will be same as whatever diagram we have, I just undo it. So the same way, like how set is functioning, the array list and linked list is functioning the same way, the linked hash set also function the same. You can able to do modifications easily, and you can do the all the operations very quickly. So for looping it will be faster, but for modification linked collection will be faster. So I'm doing the same, creating a main method linked hash set which is from java.util. I'm just declaring string type lst equal to new linked hash set lst dot add of so I'm just adding 3 elements. I'm just printing linked hash set, which is even here if you add a duplicate element it won't allow you to add it. I'm just adding geo twice. We'll see the result now, how it will actually works. See, we have only one geo, but we even tried 2 times adding the geo, but it have only one. It removes the duplicate. It's not like it removes, it actually overwrites the latest element with the old element. That's how the internal hashing will work. So these the different examples of having array list and a linked list and hash set and linked hash set. So for recap, so there are different types of classes, collection classes we have. One is iterable interface, is the parent interface. Under that we have collection interface. Under the collection interface we have 3 different types of interfaces are there: list, queue and set. So far we covered list and set. So list is having 2 classes, which is array list and linked list, and vector. Vector is not much used in programming, so for that reason I'm just ignored it. And set is having 2 types of classes, which is hash set and linked set. So the difference between the regular collection and linked collection will be this, like in the regular collection you have to loop through all the elements for making any modification, but in terms of linked list it's just linking and unlinking the elements, because linked collections will be used double linked list. So also there is a difference between set and list. List will allow duplicate elements, but set will not allow the duplicate elements. So these are all the topics we have covered. Now we can see a different set, which is a tree set, which I didn't mention here, that we can cover it now. That's a unique set, that is the reason I'm covering here. Tree set. This is also part of set interface. So there is a special advantage with using tree set. We'll see it now. So I'm just creating a main method. See guys, creating object and adding elements is not very much complex here. It will be almost same with all types of classes, collection classes. So I'm just creating tree set interface, object reference, which is tree set also comes from java.util. Just giving type as integer, tree set equal to new tree set of ts dot add of 10, or I can add it 60. I'll tell you the reason why I'm adding 60 first. ts dot add of 20, ts dot add of 20 again, ts dot add of 10. So these are I have added. So there are 4 elements I have added. One is duplicate. Obviously we know set will not allow duplicates, it will actually remove it. And I have added 3 elements. You can see the difference. I'm just printing the elements ts, or I can loop through it. I can print it so that you can understand better way. The way to loop is, for each loop, integer I equal to, what I equal to, its syntax is ts colon ts sys out I. So what I'm doing is, I just created a tree set. I'm just adding elements to it, and out of it one is duplicate, and I have added elements. What tree set will do is, it will actually remove the duplicates as the how all the set classes are working. So all the set classes are how they are working. The same way it will actually remove the duplicates, and there is additional feature in the tree set which is actually doing, by default it will do the sorting. Whenever you are adding an element, it will do the sorting of elements in ascending order by default. You can see it now. So the expected result will be 10, 20 and 60. See, 10, 20 and 60. 20 having duplicates, it removed it, and again we didn't do any sorting over here. We just added it and we just printed here. I'll print the other way also, the default way, object way. I'm just printing it. See, it just ordering the element, it is printing the elements. So I haven't done any ordering code and all, sorting code and all. It is the default nature will be, for reset it will actually order the elements. It will actually print the element. Or I can do for strings as well. We can test it for strings as well. So for that, what we will do, we just need to change the data type to string, and I'm just adding string elements, which is a for apple. I don't want to put it in first, banana. So I'm just adding another element, apple, ts dot add of dog or cat, anything you can mention. So what I mentioned is, there is no order between all the elements, so they are unordered. So even I can put this cat in between apple and banana. This is completely unordered elements. We can see the elements how they will be ordered with the tree set. See, apple, banana, cat. So this is by default. The tree set will take care of sorting the elements along with the set functionalities, which is not allowing duplicates. If you add cat twice, then it will not allow you to add it. It will simply replace it with the other cat. So only the duplicates will not allow in hasset. How hasset is functioning, along with that, sorting is an additional feature for tree set. So far we covered list related classes and set related classes. Now we can see queue. What is a queue? Queue, I can say queue everybody knows. Even everybody in the old knows what is queue. So queue is nothing but, if you just go to the theater and if you just enter into the queue, which is ticket queue, and whoever goes first, they will come out first. So that is called queue. So that's a real world we are aware of queues. The same way in Java also we have queue. So for the queue and interface, there is an implemented class which is, we have priority queue. So we can see the example how actually priority queues will work. I'm just closing all these files. For list and set related classes, set and list related classes, I'm just creating a new class which is mentioning priority queue example. I'm just creating a main method. Inside the main method, what I have to do is, the implementation for the collection will be very much easy. Everybody can able to easily understand. So I'm doing is priority queue. If you see, it comes under java.util package. I need to mention the data type. I'm just mentioning string and queue equal to new priority queue of string. That's it. So there are methods, different types of methods available. we can have add methods as we have the other collections, and also we have different naming conventions here. You see, offer is a method which is used to add an element to an instead of add, you can able to use offer also. Both the methods will do the same purpose. Poll method will be used to remove or remove method, or you can use the poll method. Peek method will be seeing for looking an element. It's kind of contains method what you have, so it will actually check an element whether that you look for the element. So if you call the peek, what will happen? If only the first person in the queue will be visible for it. So if you make a remove inside a queue, then what will happen is remove means only first person, whoever comes first comes last. First come first out. That is the queue concept. So whoever comes first, they will actually come out when you make a remove method out of queue. So these are all the different methods, and we have a standard method which is size method we have. So different methods we have, we can see how to add an element or offering an element in a queue. So I'm just using regular method which is add name one queue dot add of name 2. So I have added two names inside this. Then what I'm doing is I'm just printing. Maybe we can add more elements. 3, 4. So I just added 4 elements. What I'm doing is I'm just printing q dot peek. So it is actually print the first element whoever added first. And we can, what I'm doing is I'll actually doing a poll. We can see it now. First we can see the elements how it actually looks like. Then we can see the peak element and all. Later we can see, first we can see the whole elements how it actually looks. Then we can go by one method. Q, if you print, it's simply like how other collections are showing. It will show all the elements: name 1, name 2, name 2, name 4. What will happen if I call a peek method? So which object it will actually pick it and it will actually show it to you. The element, obviously it will be name 1, because in Q the name 1 is added first. Because of that it will actually come out first. So the standard definition for Q is first come first out. Whoever first come, they'll go out first. So this is the standard definition for Q, and we just added. That is the reason when you call a peek method, it will actually return the first element, whoever it is, actually returning first element. So what I'm doing is I'm just making a q dot poll. Poll means I'm just removing element. So we'll see what will be the output. Poll means who will come first. Name 1 is coming first. So if you run this code, then one element has to go, whoever comes first, then other elements will be there. See, the name is coming first. If you make a poll means it's kind of remove method, and the first element, because it's come first, it is coming out, it is removed first, and the other elements will be there. So these are different methods available in priority queue. You can try other methods also, like offer and all. Either instead of using add method, you can use offer as well. Offer is a method which is used to add an element. Either way you can able to work with the queues. Offer is a queue terminology, you can use it. It will work same. There's no difference between add and offer. Functionality, there's no difference, but the terminology, it is good to use. Offer method will be the preferred. So far we covered iterable interface under collection interface. Then we have covered all the classes under list interface. Vector is not much importance, so that there is no, I'm not covering that. And queue we have covered priority queue, and as we've seen, queue is having offer and poll and peek methods, which is used to adding and removing elements. The standard definition will be first come first out, and we have tested with set classes which is hash set under linked hash set. So all the set classes will not allow duplicates, and tree set also will not allow duplicate. Along with that, it will actually sort the elements by default. We don't need to do any sorting related algorithms at all. By default, tree set will take care of sorting in elements in ascending order. So the difference between list and set will be list will allow duplicates and set will not allow duplicates. Set will be maintaining hashing technology for keeping the elements. And these are about the basic collection classes and the most used collection classes. Make sure guys you should have very hands-on experience in this so that you can able to clear all the entities well. So the next collection topic we are going to discuss about map. So that is the reason I have given this page for it. It's called as map. So this is not come under this lined classes. This is come under different line of classes. So map we can discuss in next tutorial in detail. So thanks guys. Thanks for watching.